So this is sample problem 5.4 from the intermediate textbook. This is Broglie's, Broglie? I don't know how to pronounce it, to be honest, equation, which is, simply put, wavelength of a particle is equal to Planck's constant divided by the mass and velocity of the particle. Okay, so let's say we have an electron. Electron has a mass of 9.11 times 10 to the negative 31 kilograms. We want your mass needs to be in kilograms for this. You'll see why in a minute. Planck's constant is 6.626 times 10 to the negative 34th joule seconds. Okay, so these are two different units that are being multiplied together. The velocity in this problem is the speed of light, 3 times 10 to the 8th meters per second. All right, now those are our variables that we need to fill in. But there is a conversion factor we're going to need. Okay, we need to know that 1 joule is equal to 1 kilogram times meters squared divided by second squared. Okay, that comes from the equation for work and for energy. Okay, now, so you might be tempted to go ahead and just plug things in, and you certainly can. All right, so we're going to say that wavelength is equal to Planck's constant divided by mass times velocity. So we're going to plug everything in. We're going to 6.626 times 10 to the negative 34th joules per second divided by 9.11 times 10 to the negative 31st kilograms, okay, times 3.00 times 10 to the 8th meters per second. All right. Now you may notice that while you can do the multiplication down at the bottom, you're not going to cancel anything out very quickly, okay? But let's go ahead and do that to make life a little bit simpler. So 9.11 times 3 is going to be 27.33. We're multiplying, so we're going to add those exponents. So negative 31 plus 8. Would be times 10 to the negative 23rd. Okay, and that's still, so we still got kilograms, meters per second, and 6.626 times 10 to the negative 34th joules per second. And we still don't have anything that cancels out. But if we look here, we got kilograms per meters per second. That's very similar to joules. Okay, so we're getting there. So now what we're going to do is we're going to take the same thing, 6.626 times 10 to the negative 34th. We're going to substitute in for joules, right? Kilograms meters squared divided by second squared times seconds over 27.33 times 10 to the negative 23rd kilograms meters per second. Okay, now remember that when you divide by a fraction, you're going to flip and multiply by the reciprocal. So what's going to happen here is these seconds would just be down here. All right, so we're gonna have our 6.626 times 10 to the negative 34 And then we're going to have our 27.33 times 10 to the negative 30. Oh, I already did that, sorry. Times 10 to the negative 23. We're going to keep our kilogram meter squared up here. The seconds, that's the denominator, so it goes down here. Okay. And then, and we also have the kilograms down here. This is going to get flipped because it's a reciprocal. So that means you're going to have meters down here and seconds up here. Times seconds. So this becomes, because you got this second here, right? Yeah, this second's been there the whole time. So we have that second plus this second, so that becomes second squared. So now our second squares cancel, our kilograms cancel, this meter cancels out one of these, and we're left with meters. And so the answer you should get is 2.42 times 10 to the negative 12th meters. So we're going to say 6.626 times 10 to the negative 34th joules per second over 1. Now we're multiplying that by 1 over 27.33 times 10 to the negative 23rd. Now I am skipping some steps because we already worked that out, so I'm skipping this step here. Now we've got kilograms, they're going to go down here. Then we got this meters per second. Okay, that's a fraction. When you divide by a fraction, you flip it. So I'm going to have meters down here and seconds up here. Then I want to convert this joules to this, okay? All right, so this joule is equal to a kilogram meter squared over second squared. So now my kilograms cancel. This meter cancels out one of these meters. So now this is just m to the 0. This joule cancels because it's the same thing as this. This second times that second is second squared. So my seconds cancel. And so then what I'm left with is 6.626 times 10 to the negative 34th times meters divided by 27.33 times 10 to the negative 23rd. There's no units because they are all canceled. Okay, so what I end up with is 0.24, right? That's kind of what we had, times 10, 34 minus 23, 11, negative 11. But then we had to put it in scientific notation, so that means we have to move this 1 to the right, so that would be 2.42 times 10. All right, but we had to move this one more space, so that means when we multiply it out, that's one more space it has to move to the left, so this becomes negative 12 meters. You want to look at sig figs. In our original problem, we had 4 sig figs here, we have 3 sig figs here, we have 3 sig figs here, so we should have 3 sig figs in our answer, and we do. Alrighty.